Okay, good afternoon, everyone. Thanks for joining us today to talk a little bit about it's fire ratings and residential wall assemblies. That's right, Glenn, right?
Fire blocking and air sealing.
Thank
Fire
you.
blocking and air sealing.
A lot of the webinars lately, it's blending together, but
Yeah, well,
okay.
you have so many more to keep up with than just us instructors. We only have to worry about hours.
Okay, well, we'll get there. I'll get there. Thanks everyone for joining. This training is sponsored by the Colorado Energy Office with training materials created by Glenn Matthewson. And I will be going just over what we've got coming up and what other resources we have available. This is the next in our Wednesday webinar series. So we've got ComCheck and continuous installation and ResCheck Wednesday webinars coming up in the months following. And then we are also wrapping up our C406 LECC versus IECC's 2024 series tomorrow. We will be doing a residential component to this series as well. That'll likely happen in the new year. So just keep an eye out for that when that comes down the pipeline. And the other thing that I want to highlight that's on the screen are the on-demand courses that are going to be available. We're hoping to get an on-demand platform available by the end of this year and have you guys be able to take classes at your own pace. So keep an eye out for more information on that as well. If you're a jurisdiction looking for technical assistance when it comes to code adoption or implementation, we are here to help. We support the entire iCode suite. If you're looking at adopting the latest energy code, we can help with all the other codes too. So definitely take advantage of this resource and we can help in all the different ways listed on the screen. But if your jurisdiction has a specific need, don't hesitate to reach out and we can have a discussion. We've got a whole bunch of different resources. These are some of the latest resources. I got to add to this list a high level, like 2-pager summary comparison of the LECC versus the 2024 ICC so that you guys can quickly reference that. Those will be posted shortly. But if there's a resource that you guys need and we don't have it yet, we're launching a building resource survey right now, which I'll post in the chat. And it helps us to identify which resources we should create first, prioritize, or look forward to in the future at creating. So definitely give us your input, helps us to improve and make sure that you guys have the support that you need. Last but not least is my favorite resource, and I think Glenn's too, is the Colorado Codes Helpline. You submit a question on any of the iCodes, and within 2 or 3 business days, a subject matter expert gets back to you with a response. So if you have a question on plan review or inspections, or if you're a homeowner and you're just trying to see what applies, submit a question. We're here to help. All right, that is what I have to say in that presentation, but just a couple housekeeping items. Glenn, do you want me to interrupt with questions or save questions to the end?
It'd probably be best we save questions to the end. Because as typical, my presentations are pretty packed full of 60-minute, like packed full of stuff. And there's kind of, I always set things up at the beginning to kind of work through. So often questions midway are answered like 3 slides later. So happy to receive questions and make sure that the learning experience is as complete for you guys as possible. But yeah, if we can save some time at the end to do that, we may extend past our 60 minutes a little bit. But I'm here for you guys, not for 60 minutes. So let's get on with it.
That's great. Yeah. And then the last thing is when you do exit this webinar, our post-training survey will pop up. Please feel free to fill that out. It helps us to improve on these webinars and pick new topics. So, all right, I'll stop talking, Glenn, and let you take it.
Okay, let me do a little, it's always a little clunky when we got to do the switch over here. Let's see, there's the share button. Make sure I get the correct desktop to share. Slide this over. Some computer security thing. Yes, I will allow. And it looks like I'm sharing. Oh, you're seeing behind the scenes. Let's get the There we go. Okay. Is that looking good? Can you guys see my fancy cover title here, cover page?
Looks great,
All
Glenn.
right. So, hey, as we can see here, right? Air sealing and fire blocking, two absolutely related and similar subjects that have a lot of interconnection and overlapping, except they live in completely different parts of the code. And so you can see I've got the 2024 IECC up, and that represents, right, the clouds are air sealing for energy purposes and a little bit for vapor control purposes, right? We don't want to have all this uncontrollable moist air, either from inside or outside, running inside our assemblies. And so that sort of represents what I'm also teaching from is chapter 11 of the IRC. This is going to be a residential based class. That's generally what all my classes are. That's kind of my specialty, the IRC. So we kind of look at the IECC here as chapter 11. We're going to get the air sealing. But then if you want to see how that overlaps with fire blocking, well, now we're in chapter 3 of, the IRC. So that's sort of illustrated there on the right. And so that's what this 60-minute class is going to be all about. As almost always for these webinars that I do for the Colorado Energy Office, they're always brand new. It's always like you guys are always getting like a first run at these things because we're trying to create, unique and new and different things for you guys and make this program as useful as possible. So, 60 minutes as always is tough for me. So this is going to be jam-packed with stuff as I realized as I started building this class out. I'm like, yep, it's hard to just slice only 60 minutes worth. So anyway, with that, I'm not going to spend much time introducing myself. Many of you may know me. I'm a code dork. I've been in construction since age 19, started as a laborer, and I've gone through all kinds of fun stuff, and I hope there's lots of fun stuff ahead. The construction industry, one of the best choices I ever made in life as a young 19-year-old. If you want to learn more about me, you can go to glennmathewson.com. You can also email me anytime, glenn@glennmathewson.com, or you can also find me through my website, buildingcodecollege.com. Okay, enough of that. Let's get into the fun stuff here, right? Fire blocking. Let's start there. And this is gonna now just be a fire blocking class for a minute because this is the Colorado Energy Office. So I'm gonna assume that most people coming here, are coming from an energy interest. And if you have an energy code interest, you probably already know quite a bit about the energy code and, maybe been attending these webinars and other trainings that are out there. And so before we can understand the interrelations of these, I'm going to give you a deep dive into fire blocking, but trust me, this is not actually the deepest I can take it, but I do feel like I had to go deep enough for you to truly grasp this understanding of fire blocking and like own it like it's yours. So then you can see in all these different applications that you're going to face how you integrate this with energy code and air sealing. So let's get into it, right? The moment a fire starts, and we're talking now fire blocking, we're not talking about a kitchen fire that's right there, in front of you because you cooked the bacon too much and your grease caught fire. You're going to be right there facing that fire. Fire blocking is about fires that start in the concealed locations of our home, where we don't know when the fire started or where the fire started until it breaches the wall assembly or floor assembly or whatever assembly it's in. And so the moment between the fire starting and the fire breaching the wall is an absolute critical life safety time period. We want it to get out of that wall as soon as possible. We want it to hit us right here. I'm teaching this webinar. You're chilling at your computer. Boom, it came out of the wall. We instantly know. This would be the ideal situation. But what we're really, really worried about with fire safety is when we're sleeping. Because when we're sleeping, we have a delayed reaction to just about everything, right? Including a delayed reaction to any sense of maybe a little smoke coming out or a lot of smoke coming out. And then that's just real quick while I like to bring up this slide to just stress the importance of your fire alarms, guys. It's become kind of a joke in society, the beeping fire alarms. And this is not something to joke with. All of these fire safety systems in our codes that result in our safer homes, they need to work together, right? So we want that fire to breach the wall assembly quickly wherever it started, and we want it to hit that nearby smoke alarm. That's why we have smoke alarms in our sleeping rooms, smoke alarms on every floor level. We distribute them throughout the house, so the moment that fire gets out of the wall and that smoke is in our living spaces, we hit the smoke alarms. So forgive me if this is a triggering photo. It's a stock photo, and for the photo's sake, pretend that the rest of the neighborhood's not burned down. Because yes, we do have codes, and we have for a long time to keep entire neighborhoods from getting burned down. Those started from the old Chicago fires, all these, historical fires you've probably heard about. But if you just envision this one person coming back to their burnt down house, this is success. This is building code success. You get to come back alive and shed your tears for all the physical possessions that you've lost. That's correct. Yay, codes. They are not intended to protect your house. They're all about protecting you. So sad as it may look, this is success for the code. You're alive. All right, that was a hard picture. Let's go to something fun, right? Who likes playing with fire? Who likes making campfires? Or in this case, this is doing wildland urban interface clearing out at a property I have in the mountains. And every winter, we do these massive bonfires up there safely when snow's on the ground, and I report it to the county, of course. But right, what do we need to know about fires? Let's talk about fires a little bit. And I bring up the campfire picture because it's you may resonate. You may be like, oh, I get it. So let's switch gears a little bit right now. We got two Jenga blocks here. We've got Jenga blocks on the left and Jenga blocks on the right. And there's a whole lot more wood and combustible material on the complete Jenga block game right there, right? So a whole lot more wood, a whole lot more combustible materials. But now let's say that we start a fire at the bottom of these two. Which one of these is going to spread the fire faster, quicker, right? Spreading it all throughout the entire structure, quote. Well, I think right? It's going to be the one that allows more air movement through. And you know that because, those of you that like playing with fire, right? And we learning how to make campfires. You can't just throw a bunch of wood in and think that that's all it takes to create fire. You need the air, the oxygen. Hey, air. That sounds like energy code. See how all through we're going to see this relationship. And so, all right, let's get out of this Jenga blocks and campfires. I like analogies. I like to make code something you guys can feel in your day-to-day life, not just imagining these structures. But now let's imagine this big old house right here. And we get a little fire breaks out inside the walls of the basement. So it's a finished basement. Well, that fire breaks out inside that wall, and now it's going to start spreading. The hot gases and flames are spreading. They're following the oxygen, just like a chimney would draw, and your fire would draft up and draw up the chimney. All these concealed, hidden locations of your house it's basically like a big giant chimney. And what is it doing? It's spreading that fire real quickly inside the concealed locations. It's not breaching the wall until maybe it's taken over the whole house, right? So this replicates our really good campfire. We don't want our houses to be really good campfires. So what we want to do is block all these locations off. We want to compartmentalize the fire. We want to choke it off into its one little location. So what? So it will get out of the wall and get to our smoke alarms as absolutely quick as possible. So this is what we want, right? Hey, wait, more wood. But yes, more wood, but it's going to burn slower. It's going to spread slower. And so that brings us to a section, the classic section on fire blocking. You'll see why I call this the classic section. I don't do tons of code reading to you, but let's give this a little read. In combustible construction, so this wouldn't apply to CMU, concrete walls, to IFC construction, insulated concrete form construction. Wouldn't apply to metal framing. But of course, all those things would still apply for energy code. But fire blocking is focused on wood, on combustible construction. Fire blocking shall be provided to cut off both vertical and horizontal, note, concealed draft openings, and to form an effective fire barrier between stories and between a top story and the roof space. Now, a little quick note for those of you that are on the line that may be very familiar with the IBC, the International Building Code, and that term fire barrier Hey, that's an IBC term for a fire resistive assembly. We have fire walls, fire barriers, fire partitions. And I just want to mention real quick, that's not what this is talking about. This is not talking about a quote like IBC fire barrier assembly. It's just using casual language to say a barrier that will effectively, right, uh, limit that fire from getting between. And so, one thing about Fireblocking I love to point out, and remember I said this is a classic statement, and we're going to see how classic this is Fireblocking has been around, not to step on the energy code toes. Energy code's very important. I don't deny that. But I will be one to say fire blocking is more important. Oh, I know, I know. How dare I say that? But look how old fire blocking is, guys. This is not a new concept. It's been saving lives for well over 100 years. This is from my 1892 Boston Building Code. 1892 Boston Building Code. And this isn't as big as your IBC code. This code might be 3/4 of an inch in the bind. And what's in the back? Hand drawn color, three-dimensional pictures of fire stopping, it says right here. So a few things to note there. There's a second picture, not a three-dimensional. Now we get a cross section. And again, we see the term fire stop. But I thought this was a fire block class. Well, let's figure this out. Now, spoiler alert real quick. This is basically would be fire blocking today. Just that little partition head. In 1892, it hadn't yet developed to the point, where we've come today, a minimum code. What's really the minimum necessary? At this time, they were thinking, no, we need this full look brick fire stop. So the fire stop that we would have today, the fire block, is not was in the past like you had to use that just to carry this entire block of brick in there, and so much more fun stuff you see in the old codes with this. But let's move forward out of a city code and let's look at the National Board of Fire Underwriters. These are the folks that really kicked off the idea of model building codes that we adopt. This is all prior to any of our legacy code organizations like BOCA and ICBO. And this is a prize of my collection that I am going to give you a little poetry hour and I'm going to read you. This isn't a code book per se like today. It's written in very casual language, not like enforceable language as they say. But this is from 1920. I'm sure you've read the title as I'm sitting here gabbing on about it. But there are multiple pages in here expressing and explaining the importance of fire stopping. But I want to read this one to you because I think it's a little humorous and it's interesting. It drives that point home. And this is 1920, guys, over 100 years ago. And any type of building where openings exist, which would act as flues to distribute heated what? Air and gases. Sounds like energy code. From a fire in one part of a building to other portions where they might ignite combustible material. Oh, combustible construction. The history's all still in the present today. Now, here's the fun part. The added cost of such protection is very slight, and yet its value is so little appreciated, the ordinary dwelling either has no fire stopping at all, or else the work is so indifferently done as to be practically worthless. Because such work does not show when a building is completed, and because its importance is usually entirely underestimated, it's common to delegate it to a boy or some careless, incompetent person. The result is that the fire stop is so in name only, it being merely a delusive imitation, which, if called upon to fulfill its purpose, fails completely. Such work does not require any high degree of mechanical skill, but it is absolutely necessary that it be done by an intelligent, conscientious workman if it is to be efficient. Wow, like kind of interesting, right? It's like, I love the way they talk to us in this book. It's just like, to the point. Here's the deal. Stop being lazy about fire blocking just because no one sees it. It's all buried away inside the construction. Now think about the difference. Think of a little quick analogy. I wasn't expecting to say this, but it popped in mind as I'm presenting this first time ever here, right? For this class. 2012, what did we get for in the 2012 IRC and Energy Code? We got more guidance about air sealing, right? But what we got was a checklist that just told us, here are all the places that you should put in your air barriers. But how did we know if the work was being indifferently done, right? As to be practically worthless? Well, what came next? Required blower door tests. So for energy code now, we're actually making sure the energy code goals are we're testing it. We're verifying, hey, if you sloppily put in your air barriers, it's going to come out. It's going to show in your blower door test. But still, we don't have that with fire blocking. We've always relied on just, hey, you've got to try to do this well. All right, so let's move forward into actual model codes now. 1927 Uniform Building Code. And here's where I said we get that classic language. This is now 100 years ago, and you can see it's referred to fire stopping here. But let's compare that to what I just showed you for the 2024 IRC. Hey, you know, the term fire stopping, fire blocking is different, but read it. Look at that. It's essentially the same language. That's why I say classic code in there. And so, well, what's up with this? When did fire blocking become the thing? So that shift happened in the 1991 Uniform Building Code, and then it followed up in as kind in the Boca Code and the Southern Code. So about the early 90s is when we see this shift. Notice the language of the code sections all still the same. We just call it fire blocking now. And that's because a new thing came on the line. A new thing came out. The idea of penetration fire stop systems. This is completely different than fire blocking. Now, today, we're in the real world today. No more history for you now. I always love to squeeze that in because we got to know our history to know our present, to be cognizant of where our future is going, right? So, fire stopping is completely different. This is for fire resistant rated assemblies where you have a fire wall, like back to that fire barrier or fire partition, right? And you are trying to stop a fire that's out in the open on one side of the wall, and you're trying to keep it from sneaking through and burning through a plastic pipe that goes through that wall and getting to the other open side of that room. It's can apply to concealed construction, as you kind of see here, but this is because within this concealed construction, this pipe would be penetrating a fire resistant rated horizontal assembly. So from this point forward in this class, we're not talking about fire stopping anymore. And you guys out there in the world, you need to be so careful. I see this terminology just get interchanged, and it absolutely affects the understanding and the application and the products that would be purchased. You'll see a little bit more pop up on this as we carry on. So we're not called fire stopping. We are dealing with fire blocking. And I already emphasized the importance that you see twice right here. Combustible construction, wood framed construction. That's what this is about. And then let me double down. This is about concealed locations. Here you have a wall inside, say, a mechanical room, but it's not concealed. If there was an electrical outlet inside this wall and wiring, and that outlet caught fire, it's instantly in the room. It's going to be pretty quick to hit that smoke alarm. So this is only a subject of those concealed places and that sneaky fire getting around your house before your smoke alarms go off. So let's do some basics. We always got to start with basics. I never want to assume to just skip past. And we can't get any more basic than chapter 2, the definitions chapter. But hey, we also have definitions in chapter 11, our energy code definitions. So let's take a peek at these. So chapter 2, right, for all the building code definitions. This is where we get fire blocking. And we can see building materials or materials approved for use as fire blocking, installed to resist the free passage of flame to other areas of the building through concealed spaces. Notice this language is consistent, whether we're reading the section on fire blocking or the definition. Now let's look at the materials for this. That's where we're going to start right here. So building materials. And we'll find that in the code in chapter 3, it's going to list some specific materials. But then it also says, or materials approved for use as fire blocking. So remember, approved, that's a special word in the code. I'm not bringing up slides for it, but it should be something anyone dealing with code understands as quickly as possible. Approved means acceptable to the building official. Approved is a now hiring sign in the code. The code's saying, hey, we listed some materials here that have been working well for fire blocking. But then we're always hiring for other potential materials. Just show us your resume and let us see that you're qualified to do the job, right? The test information or whatever type of information that you would provide to the building official. So approval by a building official allows some discretion from the building official to say, hey, there's innovation in this world. This is a free market economy. Maybe there's other ways to achieve this. So important to understand that. Let's move now, chapter 11, and let's get our basis for what an air barrier is. An air barrier is one or more materials joined together in a continuous manner to restrict or prevent the passage of air through the building thermal envelope and its assemblies. You guys probably all know that. You're probably inundated with lots of energy code education. But what's the important thing? Let's think about materials. One or more materials. Not approved materials, not listed materials, pretty wide open, right? The focus that this is focusing on is materials that are going to restrict or prevent the movement of air. But there's a little more we need to understand about materials. And I think we could already understand it because we understand that the materials are to restrict or prevent the passage of air. So we probably could already assume this next part I'm going to show you. Here is that table I mentioned for air barriers that came about in the 2012 IRC. And this was all we had to go on before the blower door test came along. But let's look at a comment here that's about materials. We see it up here in this corner. Air permeable insulation shall not be used as an air barrier, as a sealing material. I mean, I think we kind of knew that because air permeable means it's not going to restrict or prevent the movement, right? And so all of these types of materials here, glass fiber, fiberglass, cellulose, your mineral wool, stone wool, rock wool, that's basically a trademark term now, but still used as jargon. So obviously none of these materials would be approved for air barriers. Now, let's go back and look at fire blocking because we have a whole section you can see in the top, as I mentioned, that lists out specific materials that can be used for fire blocking. And what do we find? Wait, bats and blankets of mineral wool or glass fiber, cellulose insulation. So here we start to see some differences in fire blocking and air barriers and air sealing. You can't use these air permeable materials as air barriers, but you can use these materials, and there's limitations to their applications and tests and various things a little bit outside of this class. These can be used for fire blocking. And we've already seen the language that helps us understand why. I'll bring it back again. Remember those definitions? So let's take a look at that. Resist the free passage, right? We're just resisting free passage. Sooner or later, the fire and hot gases are going to get through. Sooner or later, they'll burn out your wood fire blocking. Sooner or later, they'll push through that air permeable insulation materials. But we get it. We know that. We're okay with that. We are only resisting free passage. But now compare that language to the air barrier. We are restricting, we are preventing the passage. We see similarities, but we also see differences. So what are these other materials that we can use for fire blocking? And would they also work as resisting air movement completely? Well, 2.5-inch nominal lumber, that's certainly going to slow the burn of fire going through. And depending again on how well it's installed, that's gonna resist the air movement. So you can use minimum, you can use 1.5 inch thick, which would be 2-inch nominal lumber of any type of lumber, any grade, species, doesn't apply. Simply looking for 1.5 inch thickness of wood, that's an approved fire blocking. But you could also do 2 thicknesses of 1-inch nominal wood, like 3/4 inch thick wood. However, we know that people install this stuff sloppy, just like people install air barriers sloppy. That's the importance of testing it, right? So the caveat here is if you're using 2 thicknesses of 1 inch, you've got to offset the lap joints, right? Because we don't want those lap joints lined up and then sloppy little cuts and crooked cuts, and you're getting your hot gases leaking through. And that wouldn't be very effective either for stopping your air movement from energy code. Another option for fire blocking is 23-30 seconds wood structural panels. Now that can be your OSB or your plywood. There's a definition in the IRC for wood structural panels. And 23-30 seconds, let me just simplify this for you. That's the 3/4 inch stuff. That's the stuff you're going to find used for floors, for subfloor assemblies. 3/4 inch, it's typically tongue and groove. You only need one layer of this 3/4, whereas you needed two layers when it came to the nominal, to the wood materials. So the code sees there is a difference in how robust these materials are able to last in terms of restricting free passage, right? And so though, since you only need one layer of this, you have to back the joint somehow, or maybe splice the joint, on a supporting structural member. So here's a classic picture of fire blocking from some of my basement finish classes. And I have picture after picture showing the code problem here. That's not 23-30 seconds. That's not your 3/4 inch subfloor type material. That's your wall or roof sheathing. That's 7/16 wood structural panel. And that'd still work as a great air barrier, wouldn't it? But now that's not a sufficient fire block anymore. It's got to be 23-30 second. This is a huge mistake that happens in the fire blocking world. And then the code is great. Remember, code, people say code's the worst you can build and still be legal. But those folks don't realize how much choice you get within that minimum code. Like, which of these materials is the worst? I don't know. They're all acceptable. So maybe you got some leftover trash shelving units in your crawl space or something. Hey, throw that in your walls, add more fuel to the fire. But right, you're blocking the air. So you're still reducing that fire. So, hey, 3/4 inch particle boards in there. I've never seen it used as fire blocking. That's why I have this stock photo. 1/2 inch gypsum board. That's definitely a commonly used fire block material. 1/2 inch gypsum board. That would work as an air barrier too, wouldn't it? And of course, you get also 1/4 inch cement based mill board, which again, I don't think I could blow through that if I put my mouth up against it. So this will work for fire block and air barrier. Again, all of it depends on how well it's installed, right? But then we get to this statement of fire blocking. You can use bats or blankets of mineral wool or glass fiber, or hey, look, there's that now hiring sign. Other approved materials. So just doubling down, whoops, it works for fire blocking. It doesn't work for air sealing. All right. So there is the deep dive I wanted to take you in for fire blocking. There's way more to it. I could do probably just a 2-hour webinar on fire blocking alone. So lots more to it. I like to be careful when I'm not giving you a comprehensive education on something. I'm giving you enough to understand how we relate this with our energy code air sealing. So let's shift gears a little bit now. I guess this could be a fair time as I'm thinking to stop and make sure everyone understands fire blocking. Because I will pause, Erica, for a second. If any questions have come up where folks are curious, before we
Sure.
move on, does
Yeah.
everyone
I,
got
I got
enough
one.
fire blocking to understand and we move forward? Or any
Okay.
questions?
Yeah, I got one question. How come permeable material can be used as a fire block? Won't it promote the spread of flames through stack effect? Seems like a fire block that is also an air barrier would be best.
Yes, of course. But remember, I'm not here to tell you the best choices. I'm here to teach code. So why is it still an air permeable insulation allowed? Well, first of all, remember I said there were some additional caveats to it. And so things such as you have to have 16 inches of vertical height of that fiberglass to fill an entire cavity. And so the code is saying, okay, by the time you have had that air try to move through 16 vertical inches of fiberglass, you have, quote, right, restricted the free passage. Because again, if you can use wood for fire blocking, we know that that it will get through. We're not trying to protect your house. We're trying to give it enough time to get out of that wall assembly and hit your smoke alarms. So other language in there with insulation for fire blocking refers to like packing it very tightly, like when you put it around penetrations. And we're going to get to that. So that's kind of the answer to it. Remember, fire blocking resists free passage. It does not block it completely. We're not doing a blower door test for fire blocking. And then, yes, there is other caveats in there, other little nuances about how that insulation has to be installed. Cellulose can work, but it has to be tested under a special test procedure. But unlike energy code, there's not just a blatant outright prohibition, right? Where the energy code, we saw the clear language. You cannot use air permeable insulation, period. So hopefully that answers the question a little bit, but feel free to follow up again at the end. You'll see a little bit more about insulation as we continue.
Thanks, Glenn.
You're welcome. All right, so let's get back to now air, right? Now we're on air barriers, and I'm going to start you from this air barrier table here. Again, this is what first appeared in 2012, and it's been growing and getting more nuanced and better clarification for us. But you'll see as I go through this, where I still feel like maybe, like all code, it's never going to be perfect. We'll always have to work on clarification. So let's see kind of how some of this relates now to fire blocking. So we get this one statement here: an air barrier shall be installed in any dropped ceiling or soffit to separate it from unconditioned space. Okay. And then we get, similar language in the other column for the insulation. The insulation in any dropped ceiling or soffit shall be aligned with the air barrier. Well, there's a couple words here I want to highlight, right? Dropped ceiling, soffit. And then over here, dropped ceiling, soffit. Okay, so here's a weird one. And in this picture, let's not spend time asking why they built this soffit. I could explain, but it's illustrative of the example. This is not a fire blocking location, is it? This soffit isn't creating some interconnection or some way that we're drafting fire through the house. So we're at a soffit for an air barrier example, right? And so what did we see? That language tells us, hey, if you're going to build this soffit for whatever reason you want to, your air barrier needs to be here and it needs to be in line with your insulation there. Okay, but let's go look at fire blocking now. And let's think about those key words, right? Dropped ceilings, soffits. And so we can come here to this fire blocking section. This is one where I've showed you before it already. We talked about concealed draft openings and combustible construction. And then it's going to go on to give us these locations. And one of these is at interconnections between concealed vertical and horizontal spaces, such as occurs at soffits and drop ceilings. Hey, that sounds like air barrier stuff too. All right, our first double up location. So this, I understand, interior wall. Just bear with me. We're getting you through fire blocking. But we see here we have a dropped ceiling, or perhaps it's just a small soffit. Either way, call it what you want. We have a vertical concealed cavity, and we have a horizontal concealed cavity. Well, we don't want the interconnection between the two, right? We want to trap that fire in that lower vertical wall and get it to breach and hit the smoke alarms. But here we can see it's going to sneak right behind this ledger material and come right out here. And now it can run it all the way across the floor into the other side of the house. And so we need to fire block this. There's choices. Some folks may come and put a 2x material, like a 2x4 underneath here. Okay, that has effectively, look, my arrow is stopped, right? Now I've compartmentalized the fire. But I could also extend that vertical area up, say, all the way up in here, and put, maybe I use a drywall material or a wood structural panel material here. A lot of times people just use whatever leftover trash is laying around, and that's a good thing. Don't put it in the landfill, stuff it in the house and compartmentalize your fires. So maybe that would be it. All right, now let's look over here. Hey, great energy code picture, right? That's obviously what I took this picture for. But what else do we see? We see fire blocking in action. See right here, the way this soffit, that 2x material, this is a vertical location. And if we didn't have this solid right here, that fire blocking, we would be sneaking up into our vertical here, our horizontal soffit area, and be able to sneak up and go right through the roof. This material isn't fire blocking material. Great air barrier material, but wouldn't be fire blocking material. But in this particular case, okay, no worries. We're covered with our fire blocking at this location. But now let's look at this, right? And remember these words in the code. What did it say? Soffit, drop ceiling, or cove? Well, people would call this an arched entryway. Well, I didn't see anything in the code, Glenn, that said arched entryway. If you play word games like that with the code, I just have to say you're missing the entire intent and purpose. And that's what it's all about, isn't it, guys? Intent and purpose. If you're driving by a school zone and there's little children getting out of school and they accidentally put up like the wrong speed limit sign and it says 55, don't you know better? of what the intent and purpose would be, and I'd hope you'd still slow your speed down. So same way, this is how we want to look at the code, right? We want it to make sense. We want it to matter. We want it to be useful. Otherwise, it's just a government book with words in it. So what do we have here? I don't care what you call this. What did we create? We created a vertical connection that can connect now to this horizontal connection. And then where else could this run through? How else have we been able to sneak through our concealed locations because we've added this dropped ceiling, arched entryway, whatever. So a framer might, okay, throw some fire blocking up in these walls right here. And now I've blocked off that vertical from getting up into my horizontal. But hey, we have an attic up there, and let's presume that's a ventilated attic. And so they're going to blow a bunch of insulation. And didn't our energy code tell us we need our air barrier up here lined up with the bottom of our insulation? I mean, it just makes sense. Otherwise, what's going to happen? All your insulation, forget even air barriers, it's just going to fall through. Your blown insulation is just going to fall into your little arch here. So even outside of blower door, it just makes sense, doesn't it? But the code was very clear. Yes, this is our air sealing location. All right, let's go back and look at some more Fireblock stuff. So Fireblock location number 1. In concealed spaces of stud walls and partitions, including furred spaces. What does that mean to you? What's the point? Remember, what's the point? We want to compartmentalize the fire. And parallel rows of studs or staggered studs as followed. These are example words to drive home the point that I spent in the earlier slides, driving home what this is all about. And then we use these words to best describe that intent. And then it says as follows, in one of the locations that's going to get us in with air barriers vertically at ceiling and floor levels. So this is the slide out of a basement finish class about full fire blocking. But when it comes to air barriers, let's look at this. Hey, the ceiling line, the floor line, and then you also get it at 10-foot horizontal intervals, which doesn't have really a major relation to air barriers. So that part of it's not discussed. But what I want to focus on is at the ceiling lines. Hey, didn't we have a ceiling up here? A ceiling, a sealed ceiling. That was a funny play of words that just came to mind. I'll have to make a better joke about that if I actually plan for it. So what do we have though? We have a ceiling line and we have walls. And so we don't want that fire sneaking up this way through those walls and getting up into our attic assembly. And now you got an attic fire and you're still asleep and your smoke alarm hasn't gone off. So this is an air sealing location, but it might also end up being a fire block location, right? Depending, these are example pictures. You've got to look at the construction. You got to imagine you're a little fly flying around inside these concealed cavities and then look and see where can that fly get to, right? And if it can get from one area to another, that's fire blocking. And if it's unconditioned to conditioned space, hey, that's air sealing. And now you got to satisfy both codes. Here's another great example that comes up in the fire blocking one of just how often this mistake gets made. Look at this foam. Why wonder, gee, look at all this foam, airtight foam up there. Well, of course, because again, you have a cavity above here. But what is this? Well, it's air sealing, but it's also fire blocking. And here's another one of those examples where they didn't use the 3/4, they used the 7/16. That doesn't work. Okay. Let's look at some more stuff here. Back to air barriers. Now we're back to chapter 11, and we're in the air barrier and insulation installation table. And it tells us that an air barrier shall separate insulation in the building thermal envelope from the shower, tub, or fireplace assemblies. Okay, let's take a little gander at this. So here we have a bathtub against an exterior wall. And so, yeah, it's telling us we need to get that air barrier. It's here, that helps see it, but where's the important part? It's extending down below. So it's encapsulating that cavity, and that wall assembly is completely encapsulated and the air is held inside there. We have an air barrier separating it from all this uncontrolled air movement around your bathtub. And remember that air movement, if air is moving in, it's moving heat energy. Ooh, we don't want that for energy code. You know, right? Energy bills are expensive. What are we also moving? Warm, moist air into these assemblies. So, okay, clear as day. The words tell us that's it. Fireplace, clear as day. You just read the words, boom. The words tell you, here's this little corner built-in fireplace. And so There'll be no drywall or any, no interior wall coverings here. And so, presuming you're going to put your air permeable insulation, you are putting your air barrier on here. So, okay, now let's look at this though. Is a fireplace being installed in this? I mean, if there was going to be a hole cut here in a fireplace, we have the words right there in the book. But what if this is going to be a big, deep, built-in medicine cabinet that goes up above, or a 2 foot deep built-in cabinet? Is that any different from a fireplace? Well, no. Maybe not. Maybe it is. Let's think about the intent and purpose. What about in just the case what this is? This is just a architectural bump out because the interior design of this architecture for this house, they wanted the corner here and not here. So whether a fireplace is going to go in there or not, wouldn't we see, and as we do in the picture, well, yes, the intent is that would still be your air barrier location there. So I put the question mark because that's fair. The code's not specifically talking about that, but I'm building to something here. So we do see that this gets done this way. They do end up, the builders, they seal their air barriers off here. Even though the words don't tell us specifically every potential case, it gives us bathtubs, showers, and fireplaces. Maybe there's this section, shafts and penetrations. Hey, maybe, that's kind of like a vertical shaft, but really nothing's running through it. And so when we read this, it says duct and flue shafts. So I just bring that up to go, well, that's not really speaking specifically to that last picture I showed you. But let's look at this. This is a new bit of clarification in the 2024 edition. You can see that in blue here from ICC's website. And this is under the category for knee wall. And what does it say? Air permeable. Hey, air permeable insulation shall be enclosed inside an air barrier assembly. Yeah, it's like, yeah, because air permeable insulation is going to let uncontrolled air movement run through that assembly and potentially, like I say, bring our humid air into that. So here we can kind of see some exact examples. Right here's a classic knee wall type of example. A knee, hey, it's about as tall as my knee. Look at that. And on the back side, we see an unconditioned space. And if this is going to be an air permeable insulation, what we're going to be looking for here is an air barrier on the backside. And so we are completely encapsulating this air permeable insulation so we don't get that uncontrolled air movement through it. Okay, but what about this? Is that a knee wall? I mean, it's about it's taller than me. Look, it's a full height wall from plate to plate. So I guess the code wouldn't apply to this, huh? Because it's not as tall as my knees. Well, what if it was as tall as my waist? Oh, it didn't say a waist wall. It didn't say that. It didn't say a shoulder wall. But what's the point, guys? What's the point? There's that wall. This is an attic knee wall for the sake of what the code is telling us about. This just happens to be an interesting design house. It looks like a one-story house from the outside, but it has this loft section, this second story section. And so everything you see behind this thermoply, even though it's not a knee wall, that's all attic space on the other side. And so, yeah, I don't generally see the industry, the designers, the installers, the code officials out there playing word games with this and going, well, that's not a knee wall, so you don't have to do it, right? Uncontrolled air movement. Air moves moisture. And so that brings us back, to the fireplace example. And then that's where I'm going to bring us back to fire blocking and say that when people are trying to do their air barriers out there to meet that blower door test, like you're going to air seal the heck out of everything because when it comes time to take that test, you want to pass first time. And so you see a lot of these air barriers going on, even when the words in the book aren't specifically there, because the builders know I'm not going to do well on my blower door test. So here we can kind of look at that same example I was trying to build us up to. You have an exterior wall. You have a cavity, right? Maybe the cavity behind the bathtub, the cavity behind the fireplace, the cavity behind your knee wall. And so often the builders will put an air barrier here for their air permeable insulation in this wall cavity. So they're not getting uncontrolled air movement from the rest of this floor assembly right into their air permeable insulation. No, I can't point you to words in the book that clearly say this, but we see builders do this. And the point I want to bring up is, whoa, that's also fire blocking right here. Because notice they did not choose, the framer didn't choose to put blocking in the wall cavity like 2x4 blocks. They chose their fire blocking here. And of course, you can see it looks like they didn't use the thick enough material, happens all the time. But that's the drive home I want to make is a lot of folks will look at a soffit like this, focused on air barriers, forgetting the 100-year plus old concept of fire blocking. Okay, then we're going to get into the last little subject here. So my timing's looking okay. I warned you guys in advance. These 60-minute webinars, whew, they're tough for me, and they're always brand new for you guys. So fun stuff. My little test facility I have here. So let's look at this other part of this table. It tells us all holes. We're in the energy code now, guys. Right? This is back to chapter 11, air barrier energy code. All holes created by wiring, plumbing, or other obstructions in the air barrier assembly shall be sealed. And we know you can't do that with fiberglass, right? It said very clear, no air permeable insulation. So what do we get? We get this typical picture that we see out there in our built world going on. The double top plate of the wall was an effective air barrier, and you wouldn't get air leakage out. And let's presume this is an unconditioned space up above here. Well, now that you went and punched all these holes through it, right, we need to air seal around those between the conditioned space and unconditioned space. Okay, yeah, air sealed. There you go. Now let's go look at fire blocking. We had that same statement I've already shown you, right, that you fire block vertically at ceiling and floor levels. Okay, now we have our fire block hat on. What are the double top plates doing now? Well, they're air barriers. We already talked about that, but all those double top plates, that's also our fire blocking. And so what happens though if we take that fire blocking now and we punch a bunch of holes through it and we put our plastic pipes through, and you know, these holes that get drilled bigger than the actual item going through. And so what happens to that annular space, the little bit of space around where this spray foam is sealing up? Well, let's go back to the fire blocking locations. Well, we can see item 4 for fire blocking locations. Hey, kind of like the air barriers at openings around vent pipes, ducts, cables, and wires at ceiling and floor levels. And what? With an approved, acceptable to the building official, an approved material to what? Resist the free passage. See that language again? Air barrier, restrict, prevent. Fire blocking, resist free passage of flame. And here we get the statement of products of combustions, right? Smoke and hot gases, the products of combustions, like air. So we see that similarity. So now, from a fire block standpoint, we're going, okay, fire blocking, and we need an approved material here, or a material that's already listed in the code. Well, I don't get you into the nuance of this with the fire blocking. Well, we will a little bit, but I lied. I forgot there is a tiny little bit of history still. Chinking, and that could be a fragile word if people don't understand the context of the term chinking. Chinking is the term that was used when you're stuffing in the cracks of a log home. Back in the day when we were building log homes. And heck, they're probably using like leaves and moss or something. Anyone watch the survival like fun stuff on YouTube or whatever? People building their own shelter. They shove stuff inside those little gaps of the logs to air seal, right? To block air from coming through. And so before energy codes and before spray foam, remember fire blocking is 100+ years old. What was the method? Tightly packed insulation, mineral wool or glass fiber, tightly packed around the penetration. Per the question about it being air permeable, tightly packed so it resists free passage. Well, this was working just fine until the energy code world came along. And then now we are going to be testing this stuff under a pressure differential in a blower door test. That's a whole nother world than just resisting free passage. And so, right, this is what we see now. Imagine again, unconditioned space above. We have both a fire block location and an air sealing location. And this becomes one of those conundrums. We've been using fiberglass for this in the past, but that's no good for energy code. So what comes on the market? quote approved materials, right? And so these are just a couple random different products from different manufacturers out there. And notice the language on these boxes or on these products. These are two foam products and then like a caulking product. But what's the word? Block, 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 because that's what we're talking about, fire blocking. So fire blocking. And this is where I just want to, again, double down. This is a whole nother world. Don't you? This is a lot more expensive. If you want to go way above code, sure, this will do all of it. It'll fire block, it'll air seal, but this is a fire stop. Notice the language. This is for, you can see here, through penetrations of fire rated wall assemblies. This is the old classic when people refer to fire caulking. Now, in the realm of just single family houses, residential code, you are never really ever going to come across the need for fire stopping. There's maybe with fire separation distance, if you're less than 3 feet to the fire separation distance. So some rare instances. Now in a two-family home or in a townhouse assembly, now you have rated fire resistant walls between these, and fire stopping may come up. But in general, speaking of single family homes, get the fire stop, get it out of your mouth. Get my name out of your mouth, right? I don't know. So what do we see here? Test standards. Look, it meets all these test standards because this is a much bigger, serious deal that has to meet test standards for 1 hour, 2 hour, 3 hour, 4 hour rated assemblies. So big deal, totally different than what we're talking about. But what about test standards? What about test standards for fire blocking? Well, in fact, all you get is a statement that you don't have to resist a test standard. And so here in the rest of that statement around the vent pipes and stuff, we're back in the fire blocking section. The rest of that sentence goes on to say, the material filling this annular space shall not be required to meet the ASTM E136 requirements. So ASTM E136, just real quick, that is the test method for assessing combustibility. And what that section is saying is it doesn't have to be non-combustible. Your foam, your caulking, your alternative approved material for the annular space around penetrations, it does not have to be non-combustible. Remember, you're penetrating a piece of wood, a combustible piece of wood. So a lot of people will bring up, well, the foam melts or this and that, and people have done their own little tests and things. A lot of building departments out there, a lot of inspectors across the nation have come up with how they choose to, quote, approve or disapprove. And because that requires approval, it is subject to the building official's determination. But we sure see this stuff on the market, don't we? We sure see it being used. And that's because we have a way to test it. A way to, remember I talked about the now hiring sign? Hey, we got, these particular materials on staff as fire blocking. Would you like to join? Your foam, you can join us. But let me see your resume. Let me see you're qualified to do the job, right? So that analogy is right here to say, show me that your fancy foam stuff is going to actually work. So here is from ICCES, which is a third-party evaluation service to do comparative evaluations of materials and then provide a report. And so they have these things called acceptance criteria, which are created to say, okay, here's the criteria in which we're going to test this foam plastic. And so you've probably already read the title, right? Acceptance criteria for spray applied foam plastic used to maintain the integrity of what? Of wood fire blocking. So that's a pretty specific statement right there, right? Maintain the integrity of wood fire blocking. This doesn't just say that it's testing the foam as a fire block. It's testing it to maintain the integrity of wood fire blocking. That's an interesting line. I wonder where that comes from. It comes from the IRC, Chapter 3, Fire Blocking Integrity. The integrity of fire blocks shall be maintained. And so this is talking about it. You got that double top plate fire block, and you just drilled a bunch of holes in it for piping. You've ruined the integrity of the fire blocking. So let's test some foam plastic spray stuff to reestablish that. Now, side note, you guys, I teach building codes and that's for my passion, but I also have a passion of being a motivational speaker. So I've put together this little poster you can hang on your office. Integrity. Maintain your character. as you do your fire blocking. Ha 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 ha. You know, you got to try to squeeze some jokes in there. But that's true. Maintain your integrity. That's important of your fire blocking and your character. All right, so back on track, right? Okay, funny, funny, ha ha. We're wrapping it up. We're almost done. This is a screenshot, just one example. That ICC acceptance criteria has a lot more details in it, but this is to show you, like, oh, what are they comparing the spray foam to? Here's an example of one of the test assemblies going through a wood fire block. And look, there's your spray foam. You fill it with your free market, innovative, capitalist produced, whatever you want. That's the freedom we get here. Figure out your fire block, spray foam. This one is, about spray foam. And what do we compare it to? We compare it to the old fashioned stuff. We compare it to what we've been doing since the 1920s, since 1897. Well, I guess we got away from the brick that we saw back then. But yeah, it's comparing it right back to the fiberglass insulation. That really doesn't work anymore in this new world of energy code and air barrier. And so the important thing to recognize here, guys, it's not magic foam. One thing that we see as inspectors is people trying to get this fire block foam, and they say, I bought a fire block foam. It's fire block. And now I can just use it anywhere I want as like fire blocking. No. Like, we got to look at how it was tested. What is the manufacturer backing it for? They're not backing it. This is a piece of drywall fire blocking with a whole corner busted out and just a whole can of spray foam. It looks great air barrier, not a sufficient fire block. These fire block manufacturers, some of them have a 3/4 inch maximum gap. Some of them have a 1 inch maximum gap. And what I have seen, they're all tested according to that test criteria for holes in wood. Here's just another example. These are fire block locations, and someone is just like, well, I heard foam works. And so magic foam. No, you've got to follow. That's an approved material. It's alternate. It's as unique and creative as each one of us when we're going to try to get a job somewhere. That's why I use that as an analogy. And we have to show why our unique own little Glenn Mathewson is qualified for some job and what are the limits of what I'm qualified for. Same thing where we're looking at approving alternate fire blocking. Whew, lots of stuff to share with you in 60 minutes, and it looks like I just about did it. So I know it was fast. I know I talked quick. I know it was a big download of information. So I'm just chilling and having a good time and happy to clarify or follow up any questions you have.
Great. Thanks so much, Glenn. I think you made fire blocking the most fun of all fire blocking research I've done. So, yeah, this recording will be available for you all to reference and the slides. So if you ever want to go back and just kind of re-listen to all the material that was covered today, that is, of course, an option. I'm going to go ahead and stop the recording, but if you guys have any questions, feel free to write them in